Hey guys, welcome to our YouTube tutorial channel, Best Science Brain. Today we're going to look at the solution to NABTEB GCE November 2023, Alternative Practical Physics. So this tutorial, we're going to look at the solution, the complete solution to number 3, question on NABTEB GCE November this month, 2023, alternative practical physics. So if you're a student writing an examination, you have to pay attention and take time to go through this video and understand the concept or how this problem is solved. Then if you're not subscribed to the channel, move up to the channel's name, Best Science Brain. Under it, you have the subscription button that looks like a tiny bell. Tap on the subscription button only once and get subscribed to this channel so that you'll be following our videos, both solutions to examination questions and also tutorial videos on chemistry, physics, and mathematics. You'll be glad that you did. So let's go straight to the question. NABTEB GCE November 2023, Alternative Practical Physics. So this question number 3 is on electricity. We can see PQ. That PQ presents a uniform length of wire. We can see R under it, that's the resistance bus. We can see the ammeter by the left hand side. Then under we can see E, which is the cell that represents the EMF. Then we can see K, which represents the switch or the key for that circuit. So that circuit is labeled Fig 3. So let's go to the question. The question says the experimental setup above shows an electric circuit with battery E connected in series with an ammeter. A ammeter a key K, and a combination of a wire PQ in parallel with the resistance bus, capital I, R. Capital R are shown in the figure in Fig 3. With the resistance bus set at a given value, the ammeter reading I was obtained. The experiment was repeated with 4 other values of R, where R stands for resistance. The resistance bus was disconnected and then connected in series with the wire PQ in the circuit. The resistance bus R was then set at the same values as at first, and the ammeter reading I prime was obtained in each case. Fig 3a shows the values of the resistance bus R. Fig 3b shows the various ammeter values I prime, and Fig 3c shows the various ammeter values I. Then the question says, I read and record the values of R, that resistances. I read and record the values of I, that the current. Then triple I say read and record the values of I prime. And then IV says evaluate S equal to I times I prime, and also R inverse of resistance in each case. Then V says tabulate your readings. So we'll look at the diagram once more and understand the experiment. We'll have a wire PQ. The wire PQ connected in parallel with the resistance bus. We have an ammeter, we have a cell, we have the key. So when the key was closed, the current was taken with various values of resistances in the resistance bus. And this current we are meant to understand the current was taken to wise. So the first set of current was represented using I. The second set was represented using I for the first set of current, then I prime for the second set of current. So let's go to our readings. So for our readings, this is the resistance buses R1, R2, R3, R4, and R5. That is our Fig 3A. So we're going to read the values of resistances as we expected to do in the question. We're going to take the active resistances. The active resistance in each bus is on shaded circle. For instance, the resistance of this first bus is 1 ohm. The unshaded circle, 1 ohm. Then for our root to resistance there is 2 ohm. 2 ohm is unshaded. Then for our resistance there is, we have 2 unshaded circles. We'll add the two of them, 1 plus 2, giving us 3 ohms. For R4, resistance there is 2 plus 2, giving us 4 ohms. Then for the fifth resistance, our resistance there are going to be 2 plus 3, 2 plus 5, the unshaded circle, giving us 7 ohms. So this is how we take a reading for the resistance bus. That is the values of R. We'll now have another diagram there. That is the ammeter readings. We'll have the ammeter readings. So you see the ammeter needle. For the first current, I1, the current there is, you can see the scale moving from 0 to 0.6. And we now see that there are 10 tiny lines between 1 unit and the other. So if this is 0, the next line will be 0.1, this is 0.1, quite all right. Okay, so each digit now be, since that 10 line, divide 0.1 by 10, you have 0.01. So this will be 0.01, 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, 0.08, 0.09, 0.1. So each digit is 0.01. So going to I1 here, the reading here is, this is 0.5. So this is 0.55 at the middle. This is 0.56. So I1 is 0.56 amperes. Then I2 is at 0.5 amperes. I3 is at, this is 0.4. This is the middle. I3 at 0.45 amperes. Then I4 this is 0.4, 0.41, 0.42, 0.42 amperes for I4. Then for I5 is at this point, 0.3 is here. The middle is 0.035, 0.36, and 0.37. Okay. So as we explained earlier on, the current, we have two sets of current. So the first one we saw on Fig 3B was represented using I. This concept of current represents using I prime. I prime. So this is also under reading of current taking. And then the range of current in this one ranges from 0 to 0.3 amperes. For the Fig 3B, the current range moved from 0 to 0.6. So that is I. Current denoted using symbol I. But this one we're talking about, this 3B. For Fig 3C, the current represented using I prime. So you can see, so the same, the I1 here will be 0. This is 22. I2 is 0.2. I3 is 0.19, because this is 0.2, 0.19. Remember that one digit is 0.01. I4 is 0.18, and then I5 is 0.17. So these are values for the current for I prime in Fig 3C. So let's go to the table and see what we are asked to record. So this is the table given to us. Serial number 1 to 5, R, the resistance, I from Fig 3B, I prime from Fig 3C. We have to find S. We're going to explain what S represents. And we have to find the inverse of R. Okay, so let's go to the record. So this is the record of values. We already explained how to read R. The values of R are 1 from on this column, 2, 3, 4, and 7. Each value recorded to 4 significant figures, to 4 SF. Each value recorded to 4 SF, making all our readings consistent the whole table. So values of resistance, 1 for the first one, 1, 2, 3, 4, and 5. We already explained how we obtain these values. Let's go back to it once more. So recall resistance bus to get our R for the first resistance, but the unshaded circle 1 ohm, and that is the one we're having here. Then the con 2 ohm, and that represents the 2 we are having there. The R3, we have 2 circles unshaded, 2 plus 1, that gives us 3. That represents the 3 we're having in that third row. Then the R4, 2 plus 2, this is 4. That represents the 4 we're having, 4.000 we're having there. Then the R5, 2 plus 5, that gives us 7. That represents the 7 we're having there. So that's how we got the values of R. Then our current, we explained that before. I current, that is free from Fig 3B. Fig 3B, we have the values of our current. So we have our I1, which is reading it, which is 0.56 of our I1, the first current, 0.56. And then going to the solution, we now see that our I1 here is 0.56. That's what we have there. Then our I2, as you can see, is 0.500. So that represents the I2. And here we have 0.500 for I2. Then our I3, which is 0.45 here. So in the third row under current, 0.45. Then our I4, that gives us this value, this is 44142. And then our I5, 0.37. So 0.42 for I4 and 0.37 for I5. You go to the table, we can have 0.42 under number 4 and 0.37 for 5. So the values of R and I have been taken. Value of R is obtained from Fig 3A. Then the values of the current, set of current obtained from Fig 3B. We'll now go to Fig 3C. For Fig 3C, as you can see, our I1 here is 0.22. This is 0.2, 21, and 22. So that we're having 0.22 here, 0.22 at the first. Then our I2 is here, 0.2. I prime 2, 0.2. Then we'll go to the table, 0.2 there. Then we'll have a I3, I prime 3 as 0.19. You go to the table, you have 0.19. We have I prime 4 as 0.18. This is, remember that this is 0.1, so this is 0.5, 0.6, 0.7, 0.8, 0.9. That is we have to count well. So that is 0. Okay, it's all right. 0. The error is corrected. 0.13 is I3 is 0.18. Then our I5 is, of course, 0.17, which is 0.17. So we'll try to get a sketch of what it looks like, but we're okay. That's right. So there's no error there. Having done that, we'll now have S. We have to find S from the table, and S is nothing but the product of the two currents, I times I prime. So I times I, that gives us S, I times I prime. So multiply 0.56 by 0.22, we get 0.1232. Then this one 0.5 times 0.2 gives us 0.100. 0.45 times 0.19, that gives us 0.0855. 0.42 times 0.18, that gives us 0.07560. 0.37 times 0.17, that gives us 0.06290. So these are values of R of S. And of course, unit of resistance is ohm, unit of current is ampere, and then S is the two current applying themselves, that is ampere squared. Then we're asked to find the inverse of resistance. You go to each resistance, inverse means 1 over. So 1 over 1 will still give us the same 1. For the second resistance, 1 over 2 will give us 0.5. Then the third one, 1 over 3 will give us a recurring decimal, 0.333. We get the value to 4 SF. Then 1 over 4 will give us 0.25, then 00. 1 over 7 give us to 4 significant figures 0.1429. So you take a look at our reading, all the values are written to 4 significant figures. All the values to 4 SF, making it uniform. You want to leave your own to 3 SF, that is still okay. But make all your readings uniform. Make all your readings uniform on the whole table. So this is the solution, and this is the table for number 3, accurate, 100% accurate. So we are now going to the graph. So go to question 3V. Says plot a graph with S on the vertical axis and R prime, R S on the vertical axis, and R inverse of R on the horizontal axis. A graph of S on the vertical axis and the inverse of resistance on the horizontal axis. So we look at our table once more. What are we plotting? We are plotting S on the vertical axis, again the inverse horizontal on the horizontal axis. L represents product of the two currents, I times I prime, and then inverse of current horizontal on the horizontal axis. So here is our graph. You can see the vertical axis, S, unit of S is ampere squared. And then the scale we choose for S, you can see the scale. The greater from 0, 0.02, 0.04, 0.06, 0.08, 0.10, 0.12, 0.14 for each bus. Now that means that 0.02 for each bus. Adding 0.02 continuously, 0.02, you add 0.04, add another 0.02, you continue building your scale. So that means the scale on this axis is, we have a 0.02 for 2 cm, because this bus measured is a 2 cm, but typical of senior WAEC examination, 2 cm for each bus. So 2 cm to 0.02 unit for the vertical axis or the S axis, because what you're plotting is S here. So don't get it confused. So going to the horizontal axis, we have a 0.02, 0.2, sorry, this is 0.02. For vertical is 0.02, then 0.2, 0.4, 0.6, 0.8, 1.0. That means for the horizontal axis, which represents the inverse of R axis, unit of inverse of R is ohm by 1. So for the horizontal axis, the scale is 0.2 is 2 cm to 0.2 unit. Vertical axis 2 cm to 0.02 unit. Horizontal axis 2 cm to 0.2 unit. So you can see where the scale is written. For the S-axis here represents the vertical axis, is 2 cm to 0.02 unit. And for the R bar, that is inverse of R, which is horizontal, 2 cm to 0.2 unit. Before we start plotting our graph, we should know what one tiny line represents so you can count your reading very well. So how would I know what one line represents on vertical axis? I'll divide 0.02 by 10 lines, because there are 10 lines in one box. So you can see where we did it. On the S of vertical axis, one line is 0.02 over 10, and that will give us 0.002. So one line on the vertical axis is 0.002. So let's explain how it's being counted. Like, for instance, here is 0. The first line is 0.02. The second line is 0.04. Third one, 0.06, 0.08, 0.10, 0.12, 0.14, 0.16, 0. Let's come again. First line, I said that one line is 0.002. Sorry. First line is 0.002, 0.004, 0.006, 0.008, 0.01, 0.12, 0.14, 0.14, sorry, 0.018. I'll repeat it and get it clear so it won't be confusing. So go back to this. One line is 0.02 over 10, that is 0.002. So to make one line, then going back to the axis. So going back here is 0, 0.002. That's one line. The next one is 0.004, 0.006. The next fourth line is 0.008, 0.01, 0.012, 0.014, 0.016, 0.018, and then 0.02. So just bear in mind that one line from my calculation is 0.02 to make it easier for you. And then to note one line represents on the horizontal axis, I will divide 0.2 by 10. You see it, 0.2 by 10 gives us 0.02. 0.02. So if you count it, we have the first line will be 0.02. Then if there are 10 lines, 0.02 times 10 give us 0.2. That's very easy for you to understand. So we'll now plot our graph. You know how to plot graph? You plot the graph of S against R inverse, making sure that you can take your graph each reading to 2 decimal places. For instance, in the S column, the first reading there can take 0.12 against 1.0. The second one I'll take 0.1 against 0.50. Third one I'll take 0.086 approximately against 0.33. Then third one I'll take 0.076 against 0.25. Then the next one I take 0.063 against 0.14. So we plotted the graph, we got a straight line. So you don't expect all the points to fall into the straight line. You take the best line. The best line cut approximately across 3 points, 1, 2, and 3. Then 2 points are out of the straight line. The graph is a straight line, but did not start from the origin. It has an intercept on the vertical axis. Question VI says we should calculate the slope S of the graph. The slope of the graph. The slope of the graph S is equal to the change on vertical axis, that is delta S, all over change on horizontal axis. So you go to the graph and take any two convenient points and draw a right angle triangle. So that's our graph that where we took our slope between this point to this other point. So the value on this point, tracing it down, is 0.126. And then the lower value on the vertical axis going down, we got 0.076. Then moving this one downwards to the horizontal axis, we got about 0.8. Yeah, 0.8. Then moving this point down to horizontal axis, we got from this point, we move with a straight line down, we got 0.24. We'll trace it down. So we look at the values. So the change on the vertical axis is 0.126 minus 0.076 ampere square with the unit of the vertical axis, all over 0.8 minus 0.24 inverse of ohm. Then solving it out, 0.126 minus 0.076 gave us 0.05. 0.8 minus 0.24 gives us 0.56. Dividing, we got our slope as 0.0893 ohm multiplied by ampere squared. The next question, VII, says state two precautions you would take to obtain accurate results if you were to perform this experiment in the laboratory. So the precautions you will take if you are to perform this experiment in the lab, noting very well that this experiment was not done by you, is an alternative to practical examination. So what precautions will you take if you are to do the experiment in the laboratory? So the precautions include, the first one, I would ensure, I can say I will make sure, it's the conditional statement because you didn't do it. So I would ensure that I avoided error due to parallels while taking readings from the ammeter. That is a precaution. Number two, I would ensure that there is tight connections between the ammeter, resistance wire, and the resistance bus. We'll come again. The first one, I will ensure that I avoided error due to parallels while taking readings from the ammeter. Second one, I will ensure that there is tight connections between the ammeter, resistance wire, and the resistance bus. So these are the necessary precautions. Then question 1BI says, 3BI, sorry, it says, distinguish between the EMF of a cell and its terminal potential difference. Distinguish between the EMF of a cell and its terminal potential difference. So let's go to the solution. So for 3BI, the electromotive force or EMF of a cell represents the maximum potential difference between its terminals when no current is flowing. It is the voltage the cell can provide. I repeat myself. The electromotive force or EMF of a cell represents the maximum potential difference between its terminals when no current is flowing. It is the voltage the cell can provide. Terminal potential difference, on the other hand, is the actual voltage across the terminals when a current is flowing. This difference occurs due to internal resistance and other factors, causing the terminal potential difference to be less than the EMF. Again, terminal potential difference, on the other hand, is the actual voltage across the terminals when a current is flowing. This difference occurs due to internal resistance and other factors, causing the terminal potential difference to be less than the EMF. Go to the next question. 3BII. 3BII says, give a reason why the current is smaller in the case where the resistance bus is in parallel with the wire. Give a reason why the current is smaller in the case where the resistance bus is in parallel with the wire. We go to the next question. Triple I says 1B triple I. Calculate the EMF of a cell that gives a 2 ampere current when it is connected to a 5 ohm resistor and a 2.25 ampere current when the resistance is connected to it is 3 ohm. Repeat myself. Calculate the EMF of a cell that gives a 2 ampere current when it is connected to a 5 ohm resistor and a 2.25 current when the resistor connected to it is 3 ohm. So let's go to this question 1B triple I. For 1B triple I, the first current flowing through the cell we denote it as I1, that is 2 amperes. The resistance R1, 5 ohms. Applying Ohm's law, voltage is equal to current times resistance. So V1 now is going to be I1 times R1. Multiplying the two by substitution, 2 times 5 gives us 10 volts. Then on the other hand, they also give us another current flowing I2 2.25 volts. Resistance now changes to 3 ohm. Also applying Ohm's law, V2 or voltage, second voltage becomes I2 times R2, which is going to be substitution 2.25 times 3, giving us 6.75 volts. So the EMF is now the difference between the two voltages. That are going to be E equal to V1 minus V2. V1 is 10 volts, V2 is 6.75 volts. So we'll come back and substitute 10 minus 6.75. That will give us 3.25 volts. So we have come to the end of this NABTEB solution to NABTEB GCE, November 2023, practical physics. So stay connected to this channel. If you are not subscribed to the channel, move up to the channel's profile picture. Under it, you see this channel's name, Best Science Brain. Then under the channel's name, you see the subscription button or subscription written on it. you tap on that subscription, or you tap on the button that looks like a tiny bell and get subscribed to the channel for more videos coming on your way, and for more tutorial on chemistry, physics, mathematics, and also solution to examination questions. Stay connected to the channel for the best. Thank you.